Hi, and welcome back. In this class, we are going to present the AWS F1 platform abstraction model. As we know, an Amazon F1 instance consists of a host CPU augmented with Xilinx FPGAs. Within this context, it is now interesting to understand how these two devices can communicate and on how to gain advantages by using both of them to implement our application. Therefore, by taking a closer look at the hardware and software stacks of the AWS F1 platform, let us now explain how they can work together to provide an accelerated solution to our user application. We are working in a context in which the user is willing to design his/her application, which is the gray box in between the host and the FPGA, and to see it running at the highest possible performance because of the underlying heterogeneous architecture. In other words, this means that we are willing to allow the application designer to focus on his/her application, writing just one implementation for it, and to see it split over the underlying hardware resources at the best. We know that one of the primary motivations for using an Amazon F1 instance is to accelerate CPU-intensive and performance-sensitive applications and workloads. Therefore, the F1 acceleration works by moving compute-intensive and deeply pipelined parts of application under execution to the FPGA, where customized implementation of hardware accelerators can be provided to provide the needed performance boost. What is going to happen to the remaining part of the application? Well, that's easy. The F1 instance is not providing us only FPGA devices. Therefore, the rest of the application will be executed on the x86 CPU. At this point, we are ready to see how an abstracted model of the AWS F1 platform is working. On the left side of this figure, we updated the host chip with a gray box, which is representing the software stack running on the x86 CPU. As we can see, on the host CPU, the custom application interacts with the FPGA by using the OpenCL API, and the OpenCL runtime is responsible for managing and servicing the various acceleration requests sent to the FPGA. The same thing can be done with the FPGA. Therefore, on the right side, in the red box, we are representing the hardware components that are implemented on the FPGA. What is still missing from this AWS F1 platform abstracted model is the communication infrastructure between the CPU and the FPGA. This infrastructure is carried over the PCI Express interface. Now, within this context, at the very lowest level, the drivers handle the PCIe transfer between the two devices. As we can also see from Xilinx official documentation, the FPGA sits on the receiving end of these PCI Express transactions. Now, the point is that we need to move the data from the PCIe to the FPGA, and this can be done because the F1 instance comes with the preloaded logic to do this through the DMA, moving the data into the local DDR memory. At this point, once the DDR memory are loaded with the necessary data, the customer acceleration kernels can then read it, process the data, and write it back to the DDR using standard X interfaces.